Good morning to all. Today, in this second lecture on gears and gear train, part 2, we are going to solve two examples on gear train. Example number 1, an epicyclic gear train is shown. Gear A is annular gear, is in mesh with gear B. Gear B is in mesh with C, and C is in mesh with D, and this one is the R. Now, for this epicyclic gear train, we need to find out number of teeth on C and the speed and sense of rotation of the C. From the diagram itself, first we need to find out number of teeth on gear C. From the geometry of figure, and as the number of teeth are proportional to piece circle diameters for the same module with respect to the gears are in mesh. As these gears are in mesh, we can write one equation in terms of the radius to get the value of number of teeth on the C. So from the geometry of the figure, we can write this radius of A, that is RA, is equal to this radius of D, then 2 times radius of C, 2 times radius of B, and addition of these 3 is nothing but radius of A. Again, we need to write this in terms of the module and number of teeth. Accordingly, this is the second step. We have written in terms of the module and the number of teeth. This m by 2, from all the terms it gets cancelled from the left hand and as well as the right hand side. So from this we can get TA is equal to TD plus 2 times TC plus 2 times TB by putting value of TA as given in the numerical, that is 150 teeth, then 40 teeth for the TD, then 25 teeth for the TB. We can get the value TC is equal to 30. So this one is the first step. Now, to find speed of C, we need to tabulate the data in table of motion. So this one is the table, column number 1, column number 2, column number 3. Again it is divided into 5 sub columns. One is for arm E, then second one is for gear A, third one is for gear B, fourth one is for gear C, and fifth one is for the D. So we can rotate any convenient gear. So accordingly we have considered this A as the first gear when arm is fixed, then gear B, gear C, and gear D. So step number 1, arm fixed, gear A rotates through plus 1 revolution, that is 1 revolution in anti-clockwise direction. So arm fixed, therefore write 0 here, then gear A plus 1 revolution, write plus 1 here. Now find speed of gear B when arm is fixed and gear A rotates through plus 1 revolution. Now, as gear B is in mesh with A, we can write train value like this: NB upon NA is equal to TA upon TB. Therefore, NB is equal to TA upon TB. As NA is equal to 1, we are going to get the value NB is equal to TA upon TB. Similarly, we can write train value for this B and C. So C is in mesh with B. Therefore, NC upon NB is equal to TB upon TC. That is, NC is equal to NB into TB upon TC. Now, by putting speed of B, that which we got in the previous step, we can get the value NC is equal to TA upon TB into TB upon TC. This TB gets cancelled. We got the value NC is equal to TA upon TC. Again, train value with respect to combination of gear, that is C and D, that is ND upon NC is equal to TC upon TD. Therefore, ND is equal to NC into TC upon TD. Therefore, ND is equal to TA upon TC into TC upon TD. Finally, ND is equal to TA upon TD. In this way, we can calculate the train value, and finally we are going to write here in the first row. Again, A is in anti-clockwise direction, then B is in mesh with A. As this is internal meshing, B will rotate in the same direction, so in the anti-clockwise direction only, therefore plus sign. Then B is in mesh with C. As there is external meshing, C is going to rotate in clockwise direction, so put minus sign here. Then C is in mesh with D. D will rotate in anti-clockwise direction, so plus sign will be there, that is TA upon TD as it is. Again, second step, arm is fixed, gear A rotates through plus X revolution. Again here 0 plus X, multiply this value by X, multiply this value by X, multiply this value by X, and finally we will get this second row. Again, to count a revolution of the arm, add plus Y revolution to all elements, plus Y, plus Y, plus Y, plus Y, plus Y. Finally, total motion is equal to Y for the arm, X plus Y for the gear, Y plus X TA upon TB for the gear B, Y minus X TA upon TC for gear C, Y plus X TA upon TD for gear D. Now find speed of gear C. So speed of gear C, for that the conditions: arm revolves clockwise at 100 rpm and gear A is fixed. So from this we can get the value of Y is equal to minus 100. So, and X plus Y is equal to 0. So equation number 1 and 2, from this we will get the value X is equal to 100. Finally, speed of gear C is equal to NC is equal to total motion of C from the table, that is Y minus X T upon TC. By putting value of X and Y, we got the value of speed of C as minus 600 rpm, that is 600 rpm clockwise. Then example number 2, an epicyclic gear train as shown in the figure. The number of teeth on wheel A, B and C are 48, 24, 50 respectively. If the arm rotates at 400 rpm clockwise, find speed of C when A is fixed and speed of wheel A when C is fixed. So A, B, C, and this one is the R. Now first step, we need to tabulate the data in table of motion. Step number, then conditions of motion, a revolution of elements from the combination. First column in revolution of element, that is R. Second one gear A, then third one gear B, and fourth one gear C. Similarly, the first step, arm fixed, gear A rotates through plus x revolution, plus 1 revolution, that is 1 revolution in anti-clockwise direction. Therefore, here we are going to write 0 for gear A plus 1. Now find train value or speed of gear B and speed of gear C. Now gear A is in mesh with B. Therefore, train value with respect to these two gears, that is NB upon NA is equal to TA upon TB. Therefore, NB is equal to NA into TA upon TB. That is NB is equal to TA upon TB. This one is the final value of this NB. Then B is in mesh with C. We can write train value as NC upon NB is equal to TB upon TC. That is NC is equal to NB into TB upon TC. And finally NC is equal to TA upon TB into TB upon TC. Therefore, NC is equal to TA upon TC. So this is the table of motion. That is first row we have completed. Then second row, as usual, by following the second step, arm fixed the 0 plus x minus x TA upon TB x TA upon TC, add y revolution, then total motion this way, y x plus y, y minus x TA upon TB, y plus x TA upon TC. Now case number 1, speed of gear C. Speed of wheel C conditions are given. Arm rotates at 400 rpm clockwise, gear A is fixed. So therefore y is equal to minus 400, first equation, x plus y is equal to 0, that is second equation. From these two equations, x is equal to 400. Speed of wheel C, that is NC is equal to y plus x TA upon TC. By putting value of x and y, we got the value x is equal to speed of C is equal to minus 16 rpm. So again we are rewriting this as 16 rpm in clockwise direction. Then case number 2, speed of gear A, speed of wheel A conditions, arm rotates at 400 rpm clockwise as it is, wheel C is fixed. So total motion of arm, that is y is equal to 400 minus 400, this is equation number 3, and total motion of C is equal to 0 as wheel C is fixed. So by putting value of y in this equation number 4, we will get x is equal to 416.67, and finally speed of wheel A, that is NA, is equal to total motion of A, that is x plus y. This value we are going to write it from the table. We have written here from the table. So therefore speed of wheel A is equal to 16.67 rpm. Again rewriting it equal to 16.67 rpm in clockwise direction. Thank you.